Hello and welcome. I'm Will Sentence. I run Codesmith, a coding school online in Los Angeles and in New York City. And today, I'm going to be talking to you about functional programming, an ever increasingly popular paradigm for structuring our complex code. We're going to go under the hood of some of the fundamentals of functional programming to give you the ability to take these techniques, apply them in ways in your professional code, and combine them up with the other techniques you use to write more clean, more readable, and more debuggable code bases. Here we go. Suppose we have a quiz application. We have users saved in it, we have the users' data saved in it, their scores, their names, their avatar link, etc. We have quiz questions saved. And then we run functionality on that saved data. For example, increasing a user's score, prepending to a user's name, a term indicating they're a user, uppercasing a user's name, or propercasing, all these tasks we want to do on our data. That sounds fine. Except when we're building a full application, we have thousands and thousands of lines all changing that data. You know, this line changes the data, this line, and that data is available to all our other lines of code. Any change I make is high risk to affect the rest of my code base, my list of instructions to my computer. This is untenable, certainly at scale. What is the answer? Well, the answer has always been functions. Functions allow us to compartmentalize our code, take the 10 lines of code that are doing one task and say, these 10 lines, within them, they can only affect each other. And actually create a little mini store of data just for inside that function. So that when you run that code, you know that its only consequence, hopefully, is going to be other lines within that function. But here's the problem with that. Even with a 10-line function, those instructions are pretty complex in terms of the consequence they can have within 10 lines, certainly with our professional style of writing code. And they're still written in the style to instruct a computer. It's known as the imperative style. It's the how computer are you going to do this, not the declarative style, the nice human-readable, human style of do this, English sort of language style of do this, do this, do this. And by the way, when we run a function, we're still at risk of affecting our global store of data, that is all the rest of our code, via what's known as global variables. To the point that functions as we know them may well not be enough for a scalable code base. Imagine if we could structure our code into individual units that are small enough that each of them, every single line, is self-contained. Let's imagine that individual line's only thing that affects it would be stated right on that line as an input. And the only consequence of it would be stated right on that line as well as an output. And each of those lines would get a nice human-readable label such that when we use them, we'd know exactly what they're doing. If we could do that, it would transform how we write code. But how? How can we do that? It's functional programming. We're going to build up our application from little tiny functions, little baby functions that only do one or two small tasks. We're then going to give those little baby functions nice names that declare to the reader what those functions do. We're then going to ensure those little tiny functions have no consequences except on that line. They have no dependency on other lines, and no other lines depend on them besides the very next line to which the output is passed. And then we're going to have to rebuild up those lines. We're not going to be able to rely on JavaScript to auto-run our lines one after another. We're instead going to have to couple these lines of code, each saved as little baby tiny functions, back up into larger tasks.